Hi, good evening all. Welcome to GoScore Learning. We are the fastest growing edtech in GCC. So my name is Rahul. I am from Physics Department of GoScore Learning, and we are here. And our biggest aim is to provide education for all. So we make learning easy. Okay, I hope my audio is clear. Please give me thumbs up then. Yes. Okay. So we are dealing with chapter 9 of grade 10 science, which is none other than light reflection and refraction. Okay, so uh, this day, I hope you all the grade 10 kids have noted this date, 20th February 2025, which is Thursday, on which you are going to write your science exam, right? So in your life, this is the first public exam that you are going to write. Okay, so we have a limited time in front of you. So just like be prepared for the exam in an organized way. So here we'll be there for you to support you. So don't worry. So we'll be providing like all the science classes and mathematics classes for you. So stay tuned with GoScore Learning. Okay, so let me check the comment okay, so okay, so here there is a description that I have given for the chapter that you have in physics. Okay, as you know, there are 4 chapters that we have, like starting from light reflection and refraction, human eye and the colorful world, then electricity, magnetic effect of electric current. Okay, so as you know, there are 25 marks from physics subject for out of 80 in your board exam, and out of this 12 marks question will be coming from the first 2 chapters which is related to light, and the remaining 13 marks will be coming from the remaining chapters, electricity and magnetic effects of electric current. Okay, so don't think that it will be coming 6 marks from this chapter and 6 marks from this chapter. So don't think like that. There is no equal division. All total 13 12 mark question will be coming. So we can't expect like 6 in each. So same like there is the distribution we can't predict. So let us see how the marks are coming. Okay, so the questions are coming. So be prepared for the exam, and today we are starting with the chapter light reflection and refraction. Okay, so as you know, in this chapter we have numerical, and I just want to mention like, so in the second chapter, the human eye and colorful world, there were no numerical. Like some numericals are there which is related to the first chapter only, and in the last chapter that you have in physics, magnetic effects of electric current, there is no numericals at all, right? So in the 9th one and the 11th one, there are numericals in which we need to deal with the equation. And as you know, in light reflection and refraction chapter, that the chapter that we are going to deal with, there is less than 10 equation that we need to deal with. So the question, few question will be practicing today itself in this class. So stay tuned. Okay, so we can start the topic reflection. As you know, what is reflection? What is reflection? Okay, so in this chapter we are dealing with the topic reflection and refraction, and I'll be dealing with the topic reflection today, and the next class hopefully we can cover the refraction part. Okay, so the important equation that we have and important theories that we have, that we can start. Okay, laws of reflection that you already know. Okay, so it is be a direct question. What is state laws of reflection? So there are 2 points that you already know about it, like when light is reflected from a surface, the angle of incidence and angle of reflection are equal. I is equal to R. As you know, in this diagram, this AO, which is represented incident ray, and this OB is called reflected ray. Reflected ray. Okay, so here this angle, this point O is called the point of incidence, and we'll be drawing a perpendicular at that point to the surface. This is surface. To that surface or the reflecting surface, we'll be drawing a perpendicular at the point of incidence O, and that perpendicular is represented as ON over there. So the angle between this AO and ON, which is angle between incident ray and normal, is called angle of incidence, is called angle of incidence. We use denoted by the letter I. I is the angle of incidence, and angle between reflected ray and normal is called angle of reflection, which is denoted by the letter R. And first point is like I is equal to R. Very simple. Angle of incidence is equal to angle of reflection. Then what is the second point in that law? The incident ray, reflected ray, normal to the at the point of incidence to the reflecting surface are lying in the same plane. So that is the second point. So this can be expected like a direct question, like okay. So let us discuss few more topics like spherical mirrors. As you already know, we are dealing with today. We will be dealing with this equation, the lens mirror equation, and which is lens equation we will be discussing in the next part of this live session. Okay, so 1 by f is equal to 1 by v plus 1 by u. So what is f? F is focal length. F is focal length. And what is v? V is called image distance. Okay, better write it over here. So v is image distance. V is image distance, and u is called object distance. Object distance. Okay, so here you can see in mirror equation 1 by f is equal to 1 by v plus 1 by u, and in lens equation it is 1 by v minus 1 by u. I hope you might have noticed the change in the sign between them. So that is pretty important. Okay, so 1 by v plus 1 by u, and the other one is 1 by v minus 1 by u. Okay, so here object distance u, you should always take as a negative. Object distance is always negative when in the numerical problem, if object is placed from the mirror 10 centimeter. So according to New Cartesian sign convention, the incident ray should travel from left to right. So the left side you should take the distance as negative. From the origin we are making the measurement, so the object is placed at left side of the origin, so that distance is negative. So in every numerical problem related to this chapter, no matter whether it is concave mirror, convex mirror, plane mirror, there is no numerical at all, like concave lens, convex lens, it doesn't matter. The distance to the object, that is object distance is negative. In every numerical you should take like that. Okay, object distance is always negative, or object distance is always negative. Then in a concave mirror and concave lens, in a concave mirror and concave lens, you should take f and r as negative. F and R as focal length and radius of curvature as negative. In a concave lens as well as in concave mirror, focal length and radius of curvature is negative. Okay, so that is important. F and R, focal length and radius of curvature for a concave mirror and concave lens is negative. Okay, cave it is negative. Concave, cave it is negative. Concave, focal length and radius of curvature negative, and in convex lens and convex mirror, focal length and radius of curvature are positive. In a concave lens, in a convex lens and convex mirror, focal length and radius of curvature should be negative. So in a numerical problem, focal length of a concave mirror is given as 15 centimeter. Okay, so f is given as 15 centimeter. But while doing the numerical, as it is a concave mirror, you should take f is equal to negative 15 centimeter. I hope you know why we are taking negative sign. So in spite of New Cartesian sign convention, the focal length should be taken as negative. The focal length should be taken as negative. Okay, I hope it is clear. I hope it is clear. Okay. Okay, fine. So the focal length of a concave mirror and concave lens is negative, and focal length and radius of curvature for a convex lens and convex mirror is positive. Okay, so please keep these ideas in your mind, then only we can proceed with the numericals. Okay. Okay, now, so the simplest question that can be asked from the first part of this chapter is like defining this kind of terms. What is define center of curvature, defining pole, defining principal axis, and defining radius of curvature. So what is center of curvature? The center of the sphere of which the mirror is a part. As you know, for a spherical mirror, it is a part of there is an original sphere in which a part of the sphere is converted into mirror. So that original sphere, there is a center, right? That center of that original sphere is called center of curvature, denoted by the letter C. Denoted by the letter C. Center of the sphere by which, or sphere on which the mirror is a part of, that is the center of curvature, and radius of that sphere is called radius of curvature. Radius of that sphere is called radius of curvature, the radius of the sphere of which the mirror is a part. Okay, so that is too easy to explain and define. Okay, pole, next term is pole. Pole means the midpoint of the geometrical center or the midpoint of the reflecting surface for this mirror. Okay, so for this concave mirror, so this point is called the midpoint, right? Geometrical center. That midpoint of this reflecting surface is called midpoint of this reflecting surface is called midpoint of this reflecting surface is called okay, midpoint of this reflecting surface is called pole of the mirror. Okay, pole denoted by the letter P, capital P. Okay, then principal axis. So you have seen center of curvature and pole. A line passing through center of curvature and pole is called principal axis. Okay, an imaginary line which is passing through center of curvature and pole of the mirror is called principal axis, and the important term is principal focus. Principal focus, which is denoted by letter capital F. Okay, so there are two different definitions for principal focus, one for concave mirror and one for convex mirror. Okay, one for concave mirror and one for convex mirror. Okay, so just carefully listen my words. So how can you define concave mirror, focal length of a concave mirror? Okay, so here there are number of incident rays coming parallel to principal axis. Okay, there are number of incident rays coming parallel to principal axis. So those incident rays which is coming parallel to principal axis, after reflection they will be they will be converging to a common point, converging to a common point lying in the principal axis. So those incident rays is coming parallel to the principal axis of a concave mirror, after reflection is converging to a common point lying in the principal axis. That common point is called principal focus. That's why it is a point which all the reflected rays meet. So here it is meet, for concave it is meet, and for convex it is, as it is a diverging mirror. Okay, so one point that if I missed out is like concave mirror is also known as converging mirror. Converging mirror. Concave mirror is converging mirror and convex mirror is diverging mirror. Diverging mirror. Okay, convex mirror is diverging mirror. So when it comes to lens, it's just opposite. Concave lens is a diverging lens and convex lens is a converging lens. So you should find that dissimilarity in that term. Okay, so when it comes to mirror, concave is the converging mirror, when it comes and convex is the diverging mirror. Okay, so here this converging mirror, what they will do means the number of incident rays is coming parallel to principal axis, after reflection they will be converging to a common point lying in the principal axis. That common point is known as principal focus of a concave mirror. But for convex mirror there should be a separate definition. When a number of incident rays coming parallel to the principal axis of a convex mirror, after reflection they will be diverging. But that origin of the diverging rays, when we are extending it, it is meeting at a common point lying in the principal axis. Okay, on the other side. So it is appeared to come. It is appeared to come or appear to meet at a common point in lying in the principal axis. So that common point is known as principal focus of a convex mirror. Okay, clear? I'll repeat once again. Listen, in the case of concave mirror, which is converging mirror, when a number of incident, this is very important term, that's why I am repeating. Okay, so when a number of incident rays which is coming parallel to the principal axis of a concave mirror, after reflection, what happened to that reflected rays? They are converging to a common point. That common point is called principal focus of a concave mirror. Okay, principal focus of a concave mirror. Okay, then in the case of convex mirror, what is happening? When a number of incident rays coming parallel to the principal axis of a convex mirror, after reflection is appear to diverge. Here it is diverging, as I already mentioned. This one is converging, this one is diverging. So After reflection, the reflected rays are diverging and appear to meet, appear to come from a common point in the lying in the principal axis. That common point is called principal focus, denoted by the letter capital F. Okay, is it clear? Can I proceed? Okay, then. So here there are four terms in which like you should have an idea about it, which is erect image. I don't want to define it like how it will be for you, as you might already know about it. Okay, so erect image, inverted image, virtual image, real image. What I need to mention is an erect image is always virtual and inverted image is always real. So real image is always inverted RI, erect image is always virtual EV. So they will be existing in a pair. Whenever you are getting an erect image, it should be virtual image. Erect means upside, right side up. Erect image means which is that appears right side up. So the right side up. Inverted means just opposite, right side down. Okay, so I think you have got it. So this is a pair. So you will not get these things in the textbook. Okay, so you should keep that idea in your mind. Like erect image is always virtual, real image is always inverted. Okay, so how these things will be helpful for you means after numerical, in the end of the numerical, there will be question like give the characteristics of the image photo. So if you got it is an erect image, just write it. It will be virtual. Direct image will be virtual. So you can give it like that. If you got a virtual image, you can definitely write it like it is an erect image too. Okay, no need to think anything other than that. Okay, if you are getting an erect image, it should be a virtual too. Okay, if you are getting a real image, it will be an inverted image. You got it? I hope you have got that point. Okay, so erect image is always inverted, virtual image is always erect. Virtual image is always erect. Okay, so let me drink some water. Okay, then so I have seen most of my kids, like most of the kids I have seen, like in the grade 10 in different years. The main difficulty they feel like they feel some difficulty to draw the ray diagram. Okay, so let us complete it like which much easier way. Okay, so these are the four things that you need to remember while drawing a ray diagram. Okay, so first one is parallel focus. Second one is just reverse, focus parallel, focus parallel. Then third one, center of curvature, center of curvature, no deviation. Last one, I equal to 1. 1, 2, 3, 4. So just learn this for code. We can call it as a code. Just learn this for code. So it is easy to draw the complete the ray diagram. Okay. Parallel focus. Parallel focus. What is meant by this? When an incident ray coming parallel to the principal axis, it will be passing through the focus. That's it. That's what is meant by parallel focus. Whenever an incident ray coming parallel to the principal axis, it will be passing through focus. It is not only applicable to for concave mirror, we can apply it to convex as well, like this. When an incident ray coming parallel to the principal axis, it is appear to come from focus. It is appear to reflected as appear to coming from focus. So that is a code parallel focus. Parallel focus. Whenever an incident ray coming parallel to the principal axis, it will be passing through focus. For concave mirror, for convex also we have seen it. The same will be for lenses as well. So we will be discussing those cases once we are into refraction. Okay, so parallel focus. Now what is second point? Focus parallel. So then what will be? You can guess it. Whenever an incident ray coming through focus, it will be reflected parallel to principal axis. That's it. Whenever an incident ray coming through focus, it will be reflected parallel. That is what is meant by focus parallel. That is what is meant by focus parallel. Third one, center of curvature, no deviation. So what is meant by this? Whenever an incident ray coming through center of curvature, it will follow the same path. That's why like no deviation. It will follow the same path. It will not deviate the path. It will retrace the path. Okay, so center of curvature, same path. Same thing is applicable. So for the second thing here, whenever an incident ray coming towards the focus, it will be parallel reflected to the principal axis for convex. Okay, third one, coming towards the center of curvature retraces the same path. Retraces the same path. Okay, so that's the third point which is mentioned over here. Center of curvature. When the incident ray coming through center of curvature, it retraces the same path. There is no deviation. Okay, you got it? You got it? Yes. Okay, now last one, I equal to R. So last one, I equal to R mean doesn't mean that in rest of the cases where the I equal to R, loss of reflection is not valid. It is valid too, and we'll be discussing that question. Okay, so we'll be marking the angle of incidence and angle of reflection for those cases as well. Okay, so here is like taken as a code. Whenever incident ray coming towards P to be reflected by making same angle symmetric to the principal axis. That is what is meant by I equal to R. Okay, so whenever incident ray coming to the point P pole, it will be reflected symmetric to the principal axis. Okay, symmetry will be there. That is why I, this is I and this is R, I equal to R. I mentioned earlier, just now he mentioned like it doesn't mean that for the rest of the three cases I equal to R is not valid. It is valid. That relation will be there. Okay, for every reflection I equal to R, that condition will be there. Okay, for every reflection of light, no matter it is from rough surface or concave surface, convex surface or smooth surface, plane surface, anything, I equal to R will be valid. I equal to R will be valid. Okay, so that is a previous question too that we can discuss. Okay, so I hope you have got it. So here also, when coming towards P, it will be moving symmetry. I equal to R. Okay, so these are the four things that you need to remember for drawing a ray diagram. Okay, so now I help you for finding so how to finish a ray diagram. Okay, and before that, like before moving to ray diagram, let us see a couple of questions over there. Okay, so now first question. Okay, the laws of reflection hold true for there are options. It's a previous question. Plane mirrors only, concave mirrors only, convex mirrors only, or reflecting surface. What is the correct answer? What is the correct answer? Please give me the answer. Like just now only I mentioned it is applicable for all the reflecting surface. It is applicable for all the reflecting surface. Okay, it is applicable for all the reflecting surface. Okay, now then, so why does this a like tricky question? Why does a ray of light passing through the center of curvature of a concave mirror gets reflected along the same path after reflection? Can you answer this question, please? Anyone? Anyone knows the answer? Please put in the comment box. Is there anyone? Okay, so why does a ray of light passing through the center of curvature of a concave? So here I have mentioned like concave and convex. Okay, anyway, this will be valid for both concave and convex. Okay, so is there anyone who knows the answer for it? Is there anyone? Okay, so here the question is an incident ray. Okay, let me mark P, and this is principal focus, and this is center of curvature. Okay, so a ray of light passing through the center of curvature get reflected along the same path. Wait, so just now only we have seen this diagram. Okay, a ray of light which is passing through the center of curvature, it traces the same path. But wait, I didn't mention it here. Why it is happening so? Okay, so now we should. This is a previous question, and we should have the answer too, right? Okay, see here, I have drawn an incident ray which is coming through the principal axis. Okay, sorry, coming through the center of curvature. My mistake. Okay, coming through the center of curvature. Okay, so let's say. So this ray is coming towards the center of curvature. Sorry, coming through the center of curvature, and it's following the same path. Why? That is a question, right? So here also you can expect the same. So F and C, F and C. So incident ray which is coming towards center of curvature is you can draw it like okay. So this ray now coming towards the center of curvature, right? So I can fill it with some dashed line. Okay, so it follows the same path. Why? That is a question, right? Why? The answer is simple because it is a case of normal incidence. What is meant by normal incidence? Here, angle of incidence is equal to 0. That's why angle of reflection is 0. Both are 0. So why this angle of incidence is 0? What is angle of incidence? Angle between incident ray and normal. Angle between incident ray and normal is angle of incidence. Okay, so here how will you draw a normal to a spherical surface? So what is normal? Perpendicular to the surface. But here is a, how will you draw a normal to the spherical surface? The thing is clear. Just listen. Okay. First of all, you need to consider the point of incidence. So here in this case, this is the point of incidence, right? So at this point of incidence, as this is a spherical surface, like we need to imagine a surface in the form of a tangent at that point. As this is a spherical surface, we need to imagine a tangent. Okay. Then you already know that the radius and tangent are perpendicular. So now this tangent is the reflecting surface and the radius will be acting as the normal at that point. Okay, so the thing is clear, no need to think about tangent, you just do this thing, connect the point of incidence and center of curvature. So that will be the normal for every incidence in a spherical surface. Connect the center of curvature and point of incidence. So that lane, this lane will be the normal for every incidence in a spherical mirror or spherical lens to connect the point of incidence and the center of curvature of the mirror or the lens. That lane is acting as normal, or the radius will be acting as for a reflection at spherical surface. The radius will be the normal. Radius will be the normal. So now normal and incident ray are lying in the same lane, right? So that's why I is equal to 0 and R is equal to 0. So this is the reason. So here, when an incident ray directed towards the center of curvature or coming through the center of curvature of a concave mirror or convex mirror, whatever it is, the incident ray itself passing through the normal, which means this is a case of normal incidence. Normal incidence. So normal incidence, I is equal to 0, R is equal to 0. That's why it retraces the same path or reflected along the same path. I hope it is clear. I hope it is clear. Okay. Okay. So can I proceed? The incident ray coming through center of curvature will follow the same path. So why? Because angle of incidence here it is equal to angle of reflection, and here angle of incidence is equal to 0. Okay, so it is a previous year question and important question. Okay, so give the angle of incidence and angle of reflection for normal incidence. Okay, so give the angle of incidence and angle of reflection for the normal incidence. Okay, so what is normal incidence? Just how I mentioned. Okay, so when to this point, if the incident ray is coming perpendicular to the surface, that is what is called normal incidence. To the surface, if the incident ray is coming perpendicular to the surface, that is what is called normal incidence. Okay, in this normal incidence, this lane itself, the incident lane itself is acting as the normal. So I is equal to 0, R is equal to 0. So the angle of incidence and angle of reflection for normal incidence is 0. So just the previous question also we have discussed the same thing, right? Okay, I hope it clear. So for normal incidence, angle of incidence is equal to 0 and angle of reflection is equal to 0. Or if the angle of incidence is 0, we can call that incident as normal incidence. Okay, fine. Okay, then so an object is placed in front of a convex mirror at infinity. An object is placed in front of a convex, an object is placed in front of a convex mirror at infinity according to the new Cartesian sign convention, because like new Cartesian sign convention is like the symbol thing that you already know, so that's why I didn't explain it over there. Okay, so according to new Cartesian sign convention, the sign of the focal length, okay, sign of focal length, then what do you want? The focal length and sign of image distance is V, image distance in this case R. Okay, so focal length, what kind of mirror it is? Convex. So as you know, convex is positive, focal length is positive. So those options having negative side for the first one, it is wrong. So option B and C is deleted. Okay, then the remaining option is A and D. Okay, now what we need is V, image distance. Already know, as you already know, convex mirror always gives virtual image. Virtual image means convex mirror always gives image behind the mirror. So V, this distance is positive. So option D is the right answer. Okay, so far we didn't discuss the image formation, that will be discussing. Okay, but even though it's a direct question and which is easy to answer to, that's why I got like. Okay, so I hope it is clear. Okay, done. So option D is the right answer. Clear? Okay, those who want to repeat, just play back for 50 minutes back, then repeat it again. Okay, then draw a ray diagram. This is like one among the repeated question. So draw a ray diagram to show the path of reflected ray corresponding to the incident ray, which is directed towards the principal focus of a convex mirror. Mark on it the angle of incidence and the angle of reflection. Okay, so I know my kids have already done this for several times for this kind of question in the class. Okay, so those who didn't see the question, just see here. What do we need to do? We need to draw the reflected ray corresponding to an incident ray which is directed towards the focus. Okay, so we can draw it easily, right? Okay, so incident ray. So this is the focus and this is the center of curvature. Okay, so an incident ray for a convex, right? So in your answer sheet there won't be a convex diagram which is all convex mirror which is already drawn, but for taking the class only I have kept it over there. Okay, so then incident ray, what you need? Incident ray corresponding to, sorry, reflected ray corresponding to an incident ray which is directed towards the principal focus of a convex. Okay, so here is the focus. So a ray which is passing towards the focus. Okay, but in the diagram I am not supposed to draw like that. So we need to have like the dotted lines over some point. Okay, so this is a ray which is directed towards the focus. Okay, then I need to reduce it. Then I will be taking a copy. So in your exam, this is not the way you need to finish. You should draw with pencil and scale. Okay. So then I will be making it as like okay. So now this is a ray which is directed towards the principal focus. Okay. How it will be reflected? Already we have the code focus, focus, and parallel. Focus parallel means what? My kids will be answering that. My kids will be answering that. What is meant by focus parallel? Incident ray coming towards focus or coming through focus reflected parallel to the principal axis. That's it. Too easy. Okay, so I will be answering this question. Oh, sorry, I'll be drawing the reflected ray. Okay, we'll be passing parallel to the principal axis. Here comes the principal axis, so it will be passing parallel. Okay, it's better to take the copy. Okay, so in exam we are not supposed to take copy. Like not this copy. Don't do any kind of copy over there. Okay, so here I can like copy paste. Okay, so in exam no kind of copy paste is not allowed, as you might know. Okay, then how it will be reflected like this side parallel? No. This reflecting surface is direct towards this side, right? So it will be reflecting towards this side. Okay, so here this is the reflected ray which is passing parallel. Okay, now that is done, but one more thing is there, marked on the angle of incidence and angle of reflection. Okay, so my kids will be answering too much easily for this question because they already know how to mark the angle of incidence, right? How to mark the angle of incidence? Yes, that's it. At the from the point of incidence, this is the point of incidence, right? This is the center of curvature. Connect it. That is a normal. That is a normal. That's a normal. That's a normal. That's a normal. Okay, so what is it here? This is a normal, but to mark it over this side we need to extend it. Yeah, how easy it is, like how easy the physics is, how easy. Okay, now it is just a matter of marking I and r, just a matter of marking I and r. Okay, so incident ray normal, angle of incidence I, reflected ray normal, angle of reflection r. Okay, so you just need to mention I is the angle of incidence, r is the angle of reflection. Okay, so parallel focus, these things are not required. Okay. I is the angle of incidence, R is the angle of reflection. You secured 2 marks. You secured 2 marks. Too easy, right? Okay, so too easy. Okay, you got it? Okay, so the normal should be the point connecting a line which is connecting the point of incidence and center of curvature, that you already know. Okay, could you follow? Okay, so if any doubts are there, in that case, please comment in the comment box. Okay, can I proceed? Yes. Okay, then there's a table. The table. Okay, so I know you might have noted it. Okay, so this table is about the table is about the image formation by a concave mirror. Okay, no heading is required. My kids will be know what is meant by this table and all. Okay, and they know how to by heart this table in like 1 minute. They have already by hearted it, but they will be teaching other kids how to by heart this table. This by heart this table is pretty important in in exam. Okay, which will be helpful in different ways. Okay, so how to by heart this table, like this is there are 6 position of object and corresponding position of image formed by a concave mirror is nature and the size of the image. Okay, which is given in the textbook directly. Okay, so how to learn it, like, so you already know when let us have, yeah, so this is a diagram I required, not this heading. Okay, so yeah, so you'll be placing object over here. Okay, so we'll be placing object. This is the object. So different diagram means different position of image. Different diagram means different position of image. First of all, you are placing the object far away from the mirror, which is at infinity. Okay, so object is at infinity. Then we are moving the object towards the mirror. Okay, so here this three mark that you have seen, as you already know, this is center of curvature and this is focus. Okay, so CFP is there. Okay, so let us consider that as different stops. Okay, for the object to stop. Okay, so here this object at infinity, then it is coming towards the mirror, and the first red signal they have got is at C, but they should stop beyond C. Okay, so they will stop beyond C, then we'll be stopping at C, then the next stop is F, but before that they will be take a break between C and F, they will stop. Okay, so at infinity, beyond C, at C, between C and F, at F, between F and P, and don't need to place it on the P, because you will not have any ray diagram when the object is placed in the mirror. It will be within the focus, like between F and P. Okay, so I hope you remember the order: at infinity, beyond C, at C, between C and F, at F, between C and, sorry, between F and P. So this is the case for every ray diagram that you have in lens and lens as well. Okay, so at infinity you are placing it at infinity, beyond C, at C, between C and F, between F and P. That's it. So that's why infinity, beyond C, at C, between C and F, at F, between F and P. Okay, so take this first 5 things, repeat in the second column in the reverse order. That's become the position of image at F, between C and F, between C and F, at C, beyond C, beyond C, at infinity, at infinity. That's it. So this is why I told, easy to by heart. You know the order when we are moving the object towards the mirror. You know the order, right? You know the order. Okay, so in that order, at infinity, beyond C, at C, between C and F, at F, and then repeat in the first 5 things, repeat in the other column in the reverse order. That's become the position of image. Then for this first 5 case, the image is real and inverted. Once it is real, definitely it will be inverted. Real image is always inverted. Then look at the size of the image. Look at the size of the image. Look at the size of the image. Highly diminished or point sized. At focus, image is forming is like highly diminished, same size, enlarged, highly enlarged. That's it. From a highly point sized image to highly enlarged image, step by step. That's it. Highly diminished, same size, enlarged, highly enlarged. So here comes the first 5 things. So, but the thing is that you should write in the order. Then the image will be highly diminished, same size, enlarged, highly enlarged. From a point size image to highly enlarged image. So it is keeping increase. The size of the image is keeping increase when the object is moving towards the mirror up to focus. Up to focus. But when it is moved beyond the focus, sorry, move uh, between F and P, so the image will be forming behind the mirror, which means virtual and direct. Image will be forming as virtual and direct, and which is enlarged too. So the sixth one you need to like deal with a special case. Okay, and this is the last one. This image formation is like what you have seen in the case of shaving mirror, in the case of beauty parlor mirror, the dentist mirror. The application of this situation is what is happening over there. Okay, the shaving mirror, you are getting an enlarged virtual image. Only virtual image is the image that we can see with our naked eyes, right? So virtual image only given when object is between F and P of the concave mirror. That's why when you are having a shaving mirror, when you are having a beauty parlor mirror or the dentist mirror, when you are keep it away from you, you are not able to see your image in the mirror. But at a particular distance, if you are placing it closer, you can see that your enlarged image is getting on it. Why? Because only for the object placed. Now in that case, your face will be the object. So when you are between F and P, then only you will be getting an enlarged virtual image. Okay, only virtual image that you can see with our naked eyes. The rest of the things, real image, you require a screen to show it. Okay, so I hope it is clear, and just 1 minute or 2 minute time is required to by heart this table. Okay, now let us discuss the image formation there are 6 diagrams that you might already know, but I don't want to discuss all the ray diagram because I have already mentioned about how to draw the preliminary things that you need to know about how to draw the ray diagram. Okay, so here I'll be giving some hint to complete it. Okay, so the hints are like, so let us draw, if you want, if you have any wish to complete any particular ray diagram for different position, just mention it on the comment box so we can do it. Okay, so otherwise I'll be taking random position. Okay, so here we can go with object placed between C and F. Object placed between C and F. Object placed between C and F. So here is the object. Okay, so now there are two incident rays. The things that you need to know is there are minimum of 2 incident rays are required to complete the ray diagram. Okay, so for out of this 6 ray diagram, for all the ray diagram, you can choose first incident ray which is coming parallel to the principal axis. First incident ray which is coming parallel to the principal axis. Okay, first incident ray which is coming parallel to the principal axis. Okay, first incident ray which is coming parallel to the principal. As you know the code, parallel focus, parallel focus. So it will be reflected. It will be reflected. It will be reflecting through. It will be reflecting through focus. Okay, so this is fine, sir. We know it. We know it already. I know you know it. But to avoid the confusion, I will be sharing a simple trick for you to complete the ray diagram. Okay, so just listen here. First incident ray, you can draw parallel. That's it. Okay, parallel. So it will be reflecting through focus. Okay, for drawing the second incident ray. Okay, so there are 3 possibilities remaining that thing. The hint I have given, there is also 3 things remaining, right? Only, sorry, where is it? Where is it? Yeah. So only this we have used. There are 3 more things, right? So you can use any 3 of it in all the ray diagram, depending upon the situation. Okay. So here I can use remaining 3, anyone to draw the complete the ray diagram. Okay. So depending upon your situation, or depending upon you how you are getting it, you can complete. Okay. So the thing is, connect. This is okay. I'll call it as the head of the object. Okay. This point I'll be calling it as head of the object. So you can see 1, 2, 3, 4 red dot mark over the right. Okay, so one is being the head of the object. Okay, so thing is, connect the head of the object at any 3 red dot, so that diagram complete. What is it? Connect this head of the object at any 3 dot, any 3 red dot over there. Okay, so in your answer sheet, it's not red dot. Actually, it is center of curvature, principal focus, and pole. That's it. Connect them. Okay, so we can simply connect it like, so here I wish to connect, where is it? Yeah, this head and F. So head and F I have connected. Just extend it so that it will be moving to the mirror, right? So I have connected the head and F. Okay, then how to be reflected? So which thing you need to do? Use here focus. When an incident ray coming through focus, it will be reflecting parallel to principal axis. So here so you need to extend it. Okay, so it will be reflecting parallel to principal axis. So here comes the incident ray and the reflected ray. So here there will be an image. That's it. That's how you can complete it. Okay, so connecting. Okay, other than this connecting, sorry, where is it? Okay, connecting, rather than connecting F, we can connect, sorry, yeah, we can connect this head of the object and P. So it will be reflected towards, if it, the incident ray is coming to P, it will be reflected by making the same angle over the right. It will be moving symmetrically. So here we will be getting the ray diagram. So this is the incident ray and this is the reflected ray. So diagram completed. So that's why I told I have connected F, I have connected P, connecting head and F and head and P. Okay, connecting head and F and head and P. Okay. Okay, like, yeah. Okay, so then so far you have connected. Okay, so far you have connected head and F, head and P. So how to connect head and C? Already C is left behind, right? So he's just behind. So how to connect it? Like, listen here, just follow this. We can connect head and C in such a way that the incident ray is appeared to come from C. So it will be follows the same path. That's it. So this one is not required. Okay. So here I have connected this ray in such a way that I have connected C and head in such a way that is coming through center of curvature. So it follows the same path. It follows the same path. Okay. So that's why, 1 second. Yeah. That's how I can connect head and C. So the image will be, the diagram will be completed. Okay. So how to complete it means just extend it. Just extend it. So you'll be getting the red diagram. Okay. So you'll be getting image forming over here. So in the previous also I have got the image forming over there, right? So here I have connected head and F, head and P, head and C. Okay, that will be possible, but I can draw it too easily because I have practice. So practice make a man perfect. Okay, so if you don't think that, if you have seen like my physics class, and I have shared the trick to complete the right diagram, and which is not given in the textbook. So don't think that by knowing this you can replicate in the exam. What you need to do is you need to practice it. Like people like, even though Messi, Ronaldo, they are like good players of, right, in football. So did they directly moving to, before like World Cup match or before any tournament, did they directly moving to the field for playing? Before that, they'll be having a practice for couple of days, right? When the day before the match and the day 2 days before the match, they'll be practicing, right? So practice make a man perfect. So don't like especially for ray diagram, numerical, don't just read it. By like visualizing the things, especially in ray diagram and numerical, not going to help you. You need practice by drawing it, by doing the problem. So that's it. Okay, practice make a man perfect. So like, not like this is the case when I am drawing, when I start teaching for the first time. I need to practice for several times before coming to the class few years back. Then after taking couple of years only, I have like expertise. Not only me, every teachers are like that. Okay, so you should have a regular practice. Okay, don't think like you have got the trick, you have got the short trick by like go score live session and don't go it like directly to the exam hall or directly into class test to complete it. You should practice. Okay, so the thing I have shared is to complete the ray diagram, follow this method. First incident ray coming parallel and passing through focus. Second incident ray, you can choose it like connect the head of the object and any three red mark, any three red point over there. So your diagram will be finished. Okay, and the thing you need to connect, the thing is which is pretty important is, okay, in the ray diagram, the ray diagram is, this is, sorry, this is F and this is C, right? So this distance is X, then this should be also X. So you should mark the point F and C in such a way that you should take your scale, then mark 3 centimeter if FP, then your CF should be also 3 centimeter, because you know the relation R is equal to 2F. R is equal to 2F. Okay, so that should be there, that you should apply over there. Okay, so unless and until if you are not following this one, your ray diagram you will not get in a proper way. Your diagram is going to be wrong. Okay, so you should follow this thing. CP is 3 centimeter in your diagram. Use your scale and pencil to mark it. Then mark CF, or the mark a point C, which is 6 centimeter away from P, which is 6 centimeter away from P. You got it? Okay, so unless and until if you are not following this, your diagram is going to incorrect. Okay, so please do follow that. Please do follow that. I have seen like in several years, like students are not drawing the diagram without caring about this. If you are not care about this, yeah, I don't want to comment on your marks. Okay, so you are not getting any marks for this right diagram. Okay, so you should follow this. This is the key point which you need to mind while drawing the ray diagram. Okay. Okay, so like, okay, so here the 6 ray diagram that I have completed. Okay, so if you need any doubt clearance, or if you need to draw the ray diagram for a particular thing 1, 2, 3, 4, 5, 6 out of 6. If you want to complete anything, just let me know, like put in the chat box. We can practice over here. Otherwise, just put it in the comment over there. I'll be like, we can practice in the next class. Okay, so don't worry about it. Okay, so here the thing I need to remember, so, need to make you remember is when the object is moving towards the mirror, as you see in infinity, beyond C, at C, between C and F, at F, between F and B. 6 cases, the object is moving towards the mirror, right? So meanwhile, what happened to the image? Image is moving away from the mirror. So you have seen at focus, when the object is at infinity, image is at focus. So the image is shifting its position, and from between C and F to at C, then beyond C, then at infinity, like that. For the first 5 case, when the object is moving towards the mirror up to focus, the image is moving away from the mirror, from focus to between C and F, at C, beyond C, at infinity. Okay, when the object is moving towards the mirror, image is moving away from the mirror until the fifth case. Fifth case means object is placed at focus. Okay, when you are moving the object furthermore, the image will be formed is virtual and which is forming behind the mirror. Okay, so please keep that data in mind. And meanwhile, the size of the image is also getting increased, except the sixth one. Except the sixth one, for the first 5 cases, the image size is also keeping increased. Image size is also keeping increased. You got it? You got it? I hope it is clear. Okay, I hope it is clear. Okay, so can I proceed? Okay, then. So magnification, just remember M is equal to magnification formula. M is equal to, just remember, high by ho. High by ho. What is high by ho means? So I have seen students like who used to forget whether it is height of the image by height of the object or height of the object by height of the image. There will be h dash by h. M is equal to h dash by h. That is the formula that they have given by the teachers. Okay, then in exam hall they will be thinking about whether h dash is whether height of the object or height of the image. So that confusion will be there. So that's why my like simple suggestion is like to follow this equation. So it will be easier. Okay, what is the equation? H I by ho. That's why I read high by ho, high by ho. Okay, high by ho, hi by ho, height. So from the notation itself, it is understandable. Hi means height of the image. Ho means height of the object. Okay, so ratio, how will you define it? It is the ratio of height of the image to height of the object. It is the ratio of height of the image to height of the object. I hope it is clear. It's the ratio. How will you define it? It's the ratio of height of the image to height of the object. As it's being the ratio of two similar quantities, it doesn't have any unit. Is being the ratio of two similar quantities, it doesn't have the unit. Okay, and magnification for mirrors, M is given by M is equal to minus V divided by U. This is a formula. Magnification is equal to minus V by U. When it comes to the case of lenses, it is just V by U. So you should have that comparison. Okay, so magnification is V by U. For lenses, magnification is minus V by U. For mirrors, okay, magnification HI by HO. So we can write for lenses, for mirrors, HI by HO is equal to minus V by U. So this is required for numericals. Okay, HI by HO is equal to minus V by U, magnification. Okay, so then the importance of magnification. So imagine you have got magnification minus 2. What is the meaning? So I have seen students are oftenly saying minus 2 means 2 times image is diminished, and magnification plus 2 means 2 times image is enlarged. Completely wrong, which is completely wrong. Don't take it like that. Okay, so here positive number is the magnification. It gives only that image formed is virtual. Positive magnification is giving that image formed is virtual, which means plus 2 is virtual image. Minus 2, so negative magnification means image is real. Negative magnification means image is real. Image is real. So here minus 2 means it is real image, plus 2 means it is virtual image. Then take the number over there. So we used to say in max, take the modulus of m, magnification. Modulus means just take the number over there. So there is a like very good definition for modulus in grade 11 or grade 12 max that you are dealing with. So I don't want to explain to that much extent. Okay, simply for you grade 10 kids, you just need take the numbers without the sign. That's it. That is what you mean by modulus. For this grade, that is enough. Okay, in like if you are proceeding to science, PCB, PCM, sorry, PCM or PCMB like that, you'll be learn what is meant by modulus in the higher grade. Okay, so that doesn't matter for us. Just take the number. Modulus means take the number. So here the number is 2. Here also number is 2. So take the number. From the number only you can understand. If the number is modulus of magnitude greater than 1, image is magnified, enlarged. Magnified. Okay, it's better write enlarged, or otherwise it will be confusing. Modulus of magnitude greater than 1, image is enlarged. Okay, which means minus 2. Minus 2, negative sign indicate image is real. 2 means it is greater than 1, right? Number is greater than 1. So the image is enlarged. Okay, so modulus of magnification. So here also this I forgot, like for plus 2, plus sign indicate image is virtual image, and the 2 indicates, the number 2 indicates image is also enlarged. So in both the cases, minus 2 and plus 2, it doesn't mean that minus 2 is 2 times diminished, plus 2 is 2 times enlarged. It only means that both images are enlarged for 2 times, but minus 2 means it is real image, plus 2 means virtual image. Okay, you got it. So magnification of modulus of magnification less than 1, image is diminished. Okay, image is diminished. You got it. Then modulus of magnitude equal to 1, then it is same size. Same size. Okay, you got it. So same size image. You will be getting same size image. Okay, so this is the thing you need to remember. Okay, so magnification is hi by ho, high by ho, high by ho. Okay, so m is equal to minus v by u for mirrors, m is equal to v by u for lenses. Okay, then magnification positive is virtual image, magnification negative means real image. Then modulus of magnitude, sorry, modulus of magnification, which means the number is greater than 1. Here the numbers are 2. So number is greater than 1, image is large. Number is less than 1, image. For example, the minus 1.2 less than 1, 1.2. In these two case, the number itself is less than 1. Okay, for example, 3 by 4, magnification is 3 by 4. What does it indicate? The magnitude, the number is less than 1, so image is diminished. In that case only you can say that the image is diminished. I hope you have got it. Okay, so I hope it is clear, and those who want to repeat it, to hear it once more, just play back. Okay, then you can hear it once more. Okay, then so here there is a question like, when an object is kept within the focus of a concave mirror, an enlarged image is formed behind the mirror. This image is enlarged image formed behind the mirror. Okay, within the focus of a concave mirror. Within the focus means object is placed between F and P. My kids already know about it. Okay, within the focus means object is placed between F and P. Okay, so when the object is placed between F and P of a concave mirror, you know that image form is behind the mirror, which is virtual image. But virtual inverted, whether the virtual image is inverted, no, only real image can be inverted. Virtual image is always erect, EVRI. So virtual image is always erect. So option D is the right answer. Virtual image is always erect, and this option is completely wrong. Why? Because virtual image cannot be inverted. Okay, so virtual and erect. So option D is the right answer. Okay, clear? Then a student has focused an image of an object of height 3 centimeter. I think we need to wind up the session. Okay, like after this problem, we can wind up the session. Let me say the couple of questions which is remaining. Okay, so yeah, so after this question, we can wind up the session. Okay, after this question and like this one as well. So this is an important question. So after that, we can wind up. Okay, so when a student has focused the image of an object of height 3 centimeter on a white screen using a concave mirror of focal length 12 centimeter. So if the distance of the object is from the mirror is 18 centimeter, find the values of the following: distance of the image from the mirror and height of the image. Okay. Okay, let us find it. Okay, so basically in the using mirror equation, there are two types of problem which is coming. So one of the type is like this. They will be giving either two quantities of, there are three quantities given, right? F, U and V. So they will be giving either two quantities, F, U and V. Out of these three, either two quantities will be given, you need to find the third one. So that is a one kind of question numerical that is asking from this portion. And other than that, they will not give, they will be giving either one of F, U and V. That is the second problem. They will be giving either one of F, U and V, and M magnification will be also given. So that is the second type of problem that is asking from that you can find using mirror equation. Okay. Okay, that you can find using. We'll be after one more question. We'll be winding up the session. I know it is 8 p.m. We already covered 1 hour. Okay, let's cover one more question. After that, we can wind up. Okay, so first type of problem is they'll be giving any two of these three, and next kind of problem is they'll be giving F, U, and V, any one among them, and magnification also will be given. So this problem which is asked over here is this type. Okay, so it is easy to find that kind of question. Okay, so first of all, we need to write the given thing. Focal length is given. So focal length, you need to underline what kind of mirror it is. That is pretty important. Then only you can give the sign. Okay, focal length is 12 centimeters. So we just need to write negative 12 because focal length of concave mirror is negative. Focal length of concave mirror is negative. Okay, so F is equal to negative 12. What is it given? Height of the object. So height of the object, HO is equal to 3 centimeter positive. Height of the object is always positive. Okay, then what else is given? The distance of the object from the mirror. So distance of the object means U. U is equal to 18 centimeter. Don't write like that. Object distance is always negative. Minus 18 you should write. Minus 18. Okay, fine. What is the formula? 1 by V is equal to 1 by F minus 1 by U. Substitute the values. 1 by minus 12 minus of minus, so which means plus 1 by 18. Okay, just cross multiply it. What you will get? Just cross multiply it. So 1 by V is equal to 18 minus 12 divided by, what is 18 into 12? 18 into 12, 18, 10 times 180 plus 18 into 2, 36. 180 plus 36, 180 plus 36, 180 plus 36 is 216. Okay, so you might have to do it like normal manner. So I need to like use it to it. I can like take it like that way. Okay, so 216, but it's negative 216, right? Because it is minus 12 plus 18. Either you can go with the LCM type, that is also fine. Okay, which is equal to 6 by 216. 6 by 216, which is 1 by V, along with the negative sign. So V is equal to minus 216 divided by 6. Take the reciprocal, minus 216 divided by 6. Okay, need to divide 216, sorry, 216 divided by 6. Okay, 216 3 times 18, remaining 3, 6, 36 6 times. Oh, it is easily divisible. So minus 36 centimeter. So you should write distance of the image from the mirror. You should write the same term. Distance of the image from the mirror is 36 centimeter. You should rewrite in the answer sheet. Okay, distance of the image from the mirror is 36 centimeter. Like that you should write. Okay, one more question is there. One more question is there. What is that? Height of the image. Height of the image means you need to find HI. So here height of the image, how can you find it? Means you need to take the equation for magnification. We have M is equal to minus V by U, which is equal to HI by HO. So you can use this equation to find that answer, because height of the image, the only equation which is involved is about magnification. Okay, so you can write it like minus V. What is minus V here? V is minus 36. So minus of minus 36 divided by U. What is U? U is minus 18. So minus 18 is equal to HI. HI we need to find. HI by HO. HO is given as 3 centimeter. Okay, so minus minus getting cancel all positive. So minus 36 by 2, which is equal to minus 2 is equal to HI by 3. So HI is equal to HI by is equal to minus 6 centimeter. Minus 6 centimeter, which means it is inverted image. That is why you are getting a negative sign. So after writing this, you should write distance of the image from the mirror. As it is asked in the question, you should write separately, write it. Distance of the image from the mirror is minus 36 centimeter and height of the image is minus 6 centimeter. So that sign is also having some importance. So do like that. Okay. So yeah, I hope someone have commented the answer. Yeah, 36. Very good, Shion. Okay. So then last question for today, so that we are going to wind up. Okay, so identify the nature of the mirror and mention that two characteristics of the image form with the magnification is +6. So m is equal to +6. Okay, so you can simply mention about the characteristics. If magnification positive, I have already told you, magnification positive means image is virtual. Image is virtual. Virtual image is always erect. So you have got the two characters, right? You have got the character virtual. Magnification positive means image formed is virtual, and it is virtual image is always erect. Erect image is always virtual. So two characteristics you have already got. Then kind of the mirror, type of the mirror. So you know that there is only one mirror which can produce enlarged image. There is only one mirror which can produce enlarged image. That mirror is concave. Why? Because it is enlarged image, I am saying. Because look at the magnitude of magnification. Magnitude of magnification is equal to 6. The number is 6. 6 means image is enlarged. Only there is one mirror which can produce enlarged image. What is that? That is concave mirror. Concave mirror. Plane mirror is always producing same sized image. Convex mirror is always producing diminished image. But there is only one mirror. There is only one and only one mirror, which is concave mirror, which can produce enlarged image, same size image, and diminished image. And that is nothing but concave mirror. Okay, so that's it. So this is a simple 1 mark question or 2 mark question like that. Okay, so it is pretty easy to answer it. Okay, so I hope today's session is find good for you. Okay, so in the next class we'll be coming with, I hope to finishing 3 more problems related to mirrors in this class itself, but unfortunately we couldn't. Okay, so next class we'll be going along with that. We'll be doing 2 more numericals or 3 more numericals related to this chapter, and then we'll be moving to refraction part. Okay, so we can finish this chapter within the upcoming classes, and for next this Saturday your Paul sir is coming with yet another live session from grade 10 chapter. Okay, so you can stay tuned for Saturday. He'll be meet you at the 7 p.m. sharp. Okay, so till then, bye. Good night.